Welcome dear students to Summit for Maths. In this video we are going to discuss on the basic concepts of permutations and combinations exercise 5b question number 15 to 21. Let's discuss question number 15. There are 5 speakers A, B, C, D and E. The number of ways in which A will speak always before B is. We are given that A will always speak before B. Here let us consider A and B as a single group who are adjacent speakers, and C, D and E are 3 different other groups. So altogether we have 4 groups. The number of arrangements of these 4 groups will be 4 factorial ways. If we consider the internal arrangement of A and B, they are not going to change because A is always speaking before B. So the total number of ways is 4 factorial, which is equal to 24. Option A is the answer. Let's now discuss question number 16. There are 10 trains plying between Calcutta and Delhi. The number of ways in which a person can go from Calcutta to Delhi and return by a different train is. So from Calcutta to Delhi we have 10 trains, that is 10 options. But while returning, he returns by a different train. That means he has only 9 trains to return from Delhi to Calcutta. That means he has only 9 options. Therefore, the number of ways by which the person completes the trip is equal to 10 into 9 is equal to 19. Option B is the answer. Let's discuss question number 17. The number of ways in which 8 sweets of different sizes can be distributed among a person of different ages so that the largest sweet always goes to the younger, assuming that each one of them gets a sweet is. Let Y be the younger person who is getting the largest sweet, and the rest of the 7 person will receive a sweet each. So we have 7 sweets remaining and 7 person, which can be done in 7 factorial ways. So 1 into 7 factorial is the total number of arrangement, which is equal to 5040. Option B is the answer. Now let's discuss question number 18. The number of arrangements in which the letter of the word Monday be arranged so that the words thus formed begins with M and do not end with N is. We have MONDAY, 6 distinct letters in the word Monday. So 6 spaces for 6 distinct letters. The first position is always occupied by M because the words formed begins with M is the condition. Now let's discuss the second condition. We are also given that the last position should not be occupied by N. That is, it should not end with N. So we have O, D, A and Y that can occupy this position. So for one position, we have 4 different letters, that is 4 different options, which can be done in 4p1 ways, which is equal to 4 ways. First position is occupied by M alone, which can be done in 1 way. Now the rest of the 4 positions, we can include N here, omitting M and the letter that has occupied the last position. We have 4 other options. So for 4 options, we have 4 positions, which can be done in 4p4 ways, which is 4 factorial, which is equal to 24. Now let's find out the total number of possibilities or arrangements, which is 1 into 24 into 4, which is equal to 96. Option C is the answer. Now let's discuss question number 19. The total number of ways in which 6 plus and 4 minus signs can be arranged in a line such that no 2 minus signs occur together is. It's given that there are 6 positive signs and 4 negative signs. Now let's mark the 6 positive signs first. These 6 positive signs are nothing but identical objects, which can be considered as a repeating permutation, which can be done in 6 factorial by 6 factorial ways, which is 1 way. And now we are given that there are 4 negative signs, and the condition is no 2 negative signs occur together. So it should be in between the positive signs. For 4 negative signs, we have 7 different slots in between the positive signs. So these are the 7 slots that can be occupied by 4 negative signs in 7p4 ways divided by 4 factorial, because this is again a repeating permutation, which is equal to 7 into 6 into 5 into 4 for 7p4 divided by 4 factorial, which is equal to 24. So we have the answer as 35. Option C is the answer. Now let's discuss question number 20. The number of ways in which the letters of the word mobile be arranged so that consonants always occupy the odd places is. Let's first write the word mobile, M-O-B-I-L-E, and check the number of consonants and vowels. We have 3 consonants, M, B and L, and 3 vowels, O, I and E. We have 6 positions, of which 1, 3 and 5 are the odd positions. We are given the condition that the odd positions are occupied by vowels. So the even positions are occupied by the consonants. This can be done in 3 factorial ways for the vowels. and 3 factorial ways for the consonants. So 3 factorial into 3 factorial, which is equal to 6 into 6. Therefore, the answer is 36. Option A is the answer. Let's discuss question number 21. 5 persons are sitting in a round table in such a way that the tallest person is always on the right side of the shortest person. The number of such arrangement is. This is a circular permutation, and let this be the position of the tallest and the shortest, and we are given that the tallest person is always on the right side of the shortest person. Let us consider this set as a single group having the tallest and the shortest together, and the other 3 positions occupied by the other 3 persons, and let them be considered as single groups. So altogether we have 4 groups. In circular permutation, we know that the formula is n minus 1 factorial. So here 4 minus 1 factorial, which is equal to 3 factorial. Now let's discuss about the internal arrangement within the group T and S, which is not going to be altered because the tallest person is always sitting on the right of shortest person. So which can be done in only one way. Therefore, the total number of arrangement is 6. Option A is the answer. Hope you enjoyed this session. For much more, please subscribe to the channel Summit for Maths. Thanks for watching.